For centuries, humanity has gazed into the night sky, driven by the same burning questions. How far does the universe stretch? How small are we in the grand scheme of things? And is there truly a limit to what we can discover? Now, a new answer has begun to emerge, not from myth or imagination, but from the most powerful space telescope ever built. The James Webb Space Telescope, positioned nearly 1 million miles from Earth, has sent back data so astonishing and mind-bending that scientists worldwide are rewriting everything we thought we knew about the vastness of the cosmos. Galaxies appearing where emptiness was once expected. Black holes forming when the universe was still in its infancy. Clouds of dust giving birth to stars that we can now observe growing in real time. And this is only the beginning. With a single groundbreaking observation, Webb has not only expanded the boundaries of the known universe, but revealed a secret so immense, so intricate, and so profound that it challenges even our boldest ideas. The implications might just change our place in the cosmos forever. Webb was never intended to be just a successor to Hubble. It was designed to be something far more ambitious, a machine capable of capturing the very first light emitted after the Big Bang. Equipped with a mirror 6 times larger than Hubble's and ultra-sensitive instruments that detect infrared light, Webb can pierce through cosmic dust clouds that have long concealed the birth of stars and galaxies. Its gaze reaches billions of years back in time, revealing a universe as it was near the very beginning. When the first images arrived, scientists were stunned. What we once thought was the dark, empty void of space turned out to be filled with oceans of galaxies, each harboring billions of stars, countless planets, and potentially, life itself. But the true shock wasn't in the number of galaxies discovered, it was the timeline. Webb observed fully formed, complex galaxies, spirals, bulges, and dust lanes, in a universe only a few 100 million years old. This level of structure and maturity directly contradicts current models that predicted galaxies would form more slowly. How could the cosmos evolve so rapidly? Are our theories missing something fundamental? As Webb delves deeper into space, it reveals the vast cosmic scaffolding, the invisible web of dark matter and gas that stretches across billions of light years. Areas once believed to be voids are teeming with galaxies linked by filaments of gas, cosmic highways channeling matter and energy throughout the universe. Webb isn't just capturing images of these immense structures, it's analyzing them. Using its spectroscopic instruments, Webb measures the chemical makeup of distant galaxies, the temperature of intergalactic gases, and even detects the subtle signatures of molecules that might be the precursors to life. What has emerged is a portrait of a universe far older, far more dynamic, and far less isolated than ever imagined. Galaxies don't merely drift silently through space, they collide, merge, and feed each other in a cosmic dance that has shaped the universe since its birth. Amidst this chaotic ballet, one truth stands out. The universe was not created in silence, it was forged in fire. But Webb's uniqueness isn't just in how far it can see, it's also in how long it watches. For the first time, we can witness cosmic evolution unfolding in real time. Long-duration observations show stars being born, living, dying, collapsing into black holes, or exploding as supernovae. In distant galaxies, we observe light from stars that flared billions of years ago, long before Earth existed, and yet, here we are, watching those ancient events unfold through Webb's lens. The greatest surprise came when Webb started analyzing exoplanets and their atmospheres. Using transit spectroscopy, a technique where light passing through a planet's atmosphere is examined, Webb detected signs of water vapor, methane, carbon dioxide, and other complex molecules. While this isn't direct proof of life, it provides strong evidence that the ingredients for life may be widespread across the galaxy, scattered like seeds waiting for the right conditions to grow. Webb didn't stop at stars and planets. It turned its gaze to the vast spaces between galaxies, the intergalactic medium, which were once thought to be nearly empty. Instead, Webb found these voids filled with gases, elements, and even rogue planets, worlds drifting alone, untethered to any star, wandering silently through the cold depths of space. These free-floating planets challenge our understanding of planetary formation and raise questions about how common such nomads may be. Moreover, Webb's observations reveal that galaxies are not static objects but living entities, constantly evolving as they consume matter from cosmic filaments and eject gas through powerful explosions, reshaping themselves over billions of years. The universe is no longer seen as a collection of isolated points but as a vast, interconnected ecosystem, a self-sustaining, ever-evolving organism. Earth is but a tiny speck, nestled within one filament, inside one galaxy, on one small corner of a cosmic tapestry so vast that numbers fail to describe it. As Webb uncovers increasingly structured galaxies in the early universe, with chemical compositions mirroring those near Earth, a quiet debate has begun to surface among scientists and thinkers worldwide. Are we living in a simulation? Though once relegated to the fringes of philosophy and science fiction, the precision and order revealed by Webb's observations challenge even the most grounded researchers to reconsider. The uniformity of physical laws across billions of light years, the rapid formation of galaxies, and the mathematical precision of cosmic structures suggest an underlying design that feels almost too perfect. Quantum physicists have long speculated that reality may be a projection from a deeper, more fundamental level of existence. Now, Webb's data, revealing that even the farthest reaches of the universe follow these mysterious patterns, is breathing new life into that debate. Could our universe be a grand cosmic simulation? If so, Webb might be the first tool capable of peering behind the curtain. During one of Webb's ultra-deep field scans, a strange anomaly appeared. In a distant cluster of galaxies, the telescope recorded repeated signals embedded in the light, a pattern initially dismissed as glitches. But after meticulous verification, it became undeniable. These signals are real, non-random, and distinctly patterned. Scientists remain baffled. The signals do not resemble natural radio bursts, nor do they match any known cosmic phenomena. Instead, they pulse at intervals that suggest encoded information. What are these signals? Are they the remnants of an advanced civilization, echoes from the Big Bang itself, or something beyond our current understanding? The truth remains elusive. But one thing is clear. Something out there is communicating, and Webb is the first to listen. Webb's discoveries also challenge our understanding of dark matter and dark energy, the invisible forces that together comprise over 95% of the universe. By mapping subtle distortions in light from distant galaxies, Webb has begun tracing the gravitational fingerprints of dark matter in unprecedented detail. However, its behavior isn't consistent. In some areas, dark matter clumps predictably, in others, it spreads out like a fog. Even more startling is the possibility that dark energy, the mysterious force driving the universe's accelerated expansion, is not a constant force, but one that varies over time. These revelations shake the foundations of cosmology, forcing us to question our assumptions about time, gravity, and even the nature of reality. Could these fundamental concepts be emergent properties, rather than fixed constants? Among Webb's lesser-known but most profound missions is the search for biosignatures, chemical indicators that hint at the presence of life. Already, Webb has scanned multiple exoplanet atmospheres, detecting organic molecules, water vapor, and carbon dioxide. Recently, it made a remarkable discovery: the spectral fingerprint of dimethyl sulfide, a compound on Earth produced almost exclusively by living organisms, on a planet orbiting a red dwarf star 120 light-years away. While this is not definitive proof of life, it is the closest we have come to detecting signs of life beyond our solar system. If confirmed, this discovery would represent one of the greatest milestones in human history, confirming that life exists elsewhere in the universe and that Webb was the telescope that first found its breath among the stars. The James Webb Space Telescope was built to answer humanity's deepest questions. What it has done, however, is far more transformative. It has shattered our assumptions and expanded the limits of human knowledge. From galaxies that shouldn't exist so early in cosmic history, to signals that challenge our understanding of physics, to the chaotic behavior of dark matter, and finally, to molecules that hint at life, Webb is rewriting the story of the universe. And perhaps the greatest discovery isn't a distant planet or molecule. It's the humbling and awe-inspiring realization that we have only just begun to comprehend the vast canvas upon which we exist. Behind every new revelation lie countless more mysteries waiting to be explored. As the telescope continues its mission, peering ever deeper into space and further back in time, one truth becomes clear. We are no longer the same civilization that launched Webb into the void. We are explorers, not just of stars and planets, but of the profound truths that define our existence. Because when the James Webb Space Telescope stares into the cosmic darkness, the universe is watching back.